Hello guys, the question today is so that for a discrete frequency distribution ST means standard deviation which is denoted by sigma is not greater than range. So what we have to prove is standard deviation is not greater than range, which means that standard deviation should be less than or equal to range. Okay, we have to prove this thing, and for this we will let if x bar is the average or is the mean, okay, mean of x1 x2 dot 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 and xn, okay, then we know that xi minus x bar which should be greater than range. Okay, I will tell you how the solution come is we know that what is average. Okay, x bar is average, so average means x initial, xi means initial, our initial term. In our case xi is x1. Okay, so xi will be x1 and x n or xf will be final value. Okay, so xi should be average should be greater than xi, so xi should be less than average and average should be greater than xn. I assume that you know this reason because average lies in the middle. Okay, average is greater than initial value and average is less than final value. If we have 1 2 3 and if we take the average we will get 2 average, so 2 is greater than 1, so I say wrote 2 is average is greater than 1 is initial value, and 3 is the final value, so 2 will be less than 3. Okay, so with this relation I present you here this relation, and if we will divide if we will subtract here xi, so xi minus xi will be 0, and which will be greater than equal to x bar minus xi. Okay, and here xn means final value, so it will be xn minus xi. So we just ignore that 0 term and we will write x bar minus xi, and this is the final value minus initial value is the range. Okay, you know what is range. Range is final minus initial, the greatest value minus the smallest value, so it is the greatest minus smallest, and that will be our range, so we'll write r. Okay, so if we take the modulus, then we can write xi minus x bar is greater than equal to r. Okay, so this relation has come from this here. Sorry, so now with this now we can say it is r is range. So also we have another formula, that is sigma square, which is standard deviation, square of standard deviation. Its formula is summation xi minus x bar whole square by n. Okay, it is formula summation x minus x bar by n, so it is the formula of sigma square. So sigma square will be equal to 1 by n times summation, and we will write it is for the 1th value. It means that xi is initial value, so we have to write the value of everything, just like xi minus x bar and xi is x1, so it's square, and plus x2 minus x bar square plus dash and xn minus x bar square. So we wrote everything for the whole number sub series, and now which will be like if we write 1 by n and summation, and this term is here, you can see this is r. Okay, so the square we can say r square, but here the sign is less than equal to, so we will put less than equal to here, and plus r square, and this will be up to here r square. Okay, so now we can write that sigma square should be greater than equal to 1 by n, and this is the summation of r square, it is n times r square. Okay, you know that if r square if there are n r square, then we can write n times r square. Okay, so n cancel out, so sigma square is greater than r square, and this implies that sigma is greater than equal to, smaller than is equal to r. Okay, so this is what we have to prove, and we already proved it within 5 minutes. Thank you.